Assalamu alaikum. Requesting hosts to start the program.
Assalamu alaikum, everyone. I hope I'm audible.
Yes, you are.
Thank you for confirming. A very good evening and a warm welcome to all of you. I'm Zarin Tasneem, Vice Chairperson of Women in Engineering Affinity Group of IEEE IIUC Student Branch, and I'll be your host for today. I hope that you all are safe with your family and friends in the midst of this pandemic. So first of all, on behalf of our IEEE Robotics and Automation Society, IIUC SP, and WIE Affinity Group, I would like to thank everyone who joined us today from Bangladesh, India, USA, Pakistan, Tunisia, Peru, Egypt, Nepal, and Indonesia for today's session through Zoom. We are also live on Facebook, so you can catch up with us there and share our live with your friends and family as well. I'll request our executives to drop the link of our Facebook Live in the chat section, please, so that everyone can find it easily. Now, I would like to welcome my co-host for today's session as well.
Assalamu alaikum. I'm Sarah Karim, Vice Chairperson of IEEE Robotics and Automation Society, and I'll be your co-host for today's session. Today, we have our honorable chief guest, Professor Dr. Muhammad Akhtar Said sir, guest of honor, Anamita Bhakta ma'am, session chair, Professor Shamsul Alam sir, and our honorable keynote speaker, Maya Nasr. We are really honored to have you guys among us. We also have our advisor of IEEE Robotics and Automation Society, Muhammad Abdul Qadir sir, Women in Engineering Affinity Group Advisor, Ishrat Binta Habib ma'am, and Tanzim Mushtari ma'am among us. Without your guidance, we wouldn't have been able to pull off the event successfully. Thank you so much for joining with us today within your busy schedule. So now let's begin today's auspicious event with the praise of the most merciful Almighty Allah. So for the recitation of the Holy Quran, I look forward to the presence of Muhammad Abdul Rahman, Assistant General Secretary, IEEE IIUC Student Branch. Muhammad Abdul Rahman, can you hear me? I would like to call Muhammad Abdul Rahman, Assistant General Secretary, IEEE IIUC Student Branch. Abdul Rahman, can you hear me? I think he is not present within us. So, in the meantime, I would like to call Tanvir Alam, Treasurer of IEEE RAS.
Thank you, Paraguay, for. I'd like to recite Surah Falaq. Bismillahirrahmanirrahim. Alam tara kayfa fa'ala rabbuka bi ashabil fil alam yaj'al kaydahum fi tadlil wa arsala alaihim kaydan ababil tamihim bi hijaratin min sijil wa ja'alahum ka'asfin min makul. Thank you.
Thank you, Abdul Rahman, for your wonderful recitation.
Thank you, Abdul Rahman. But it was Tanvir Alam, I guess. I'm sorry.
Oh, sorry.
Abdul Rahman was disconnected. Thank you, Tanvir Alam, for your wonderful recitation. Now, moving on, I would like to call our chief guest, Professor Dr. Muhammad Akhtar Said, sir, Dean of Faculty of Science and Engineering, International Islamic University of Chittagong, to share a few wise words with us.
Bismillahirrahmanirrahim. MOXIE, Women in Aeronautics and Space. organized by IEEE Robotics and Automation Society, IUC Student Branch Chapter, and IEEE IUC Student Branch, we Affinity Group. Assalamu alaikum warahmatullah. Honorable Chair of this session, Professor Muhammad Shamsul Alam, Guest of Honor, Anamika Bag, Special Guest, Engineer Muhammad Abdul Kader, and today, our main attraction, our Honorable Keynote Speaker, Maya Nasr, one of the PhD researcher of NASA-JPL Mission, and our each audience is waiting for her speech for a long days. I'm also happy to participate in these types of seminar presentation. Here the term pre-phase MOXIE is not very much familiar with what to us. Usually MOXIE collects carbon dioxide from the Martian atmosphere, then electrochemically splits the carbon dioxide molecules into oxygen and carbon dioxide. Basically, this is the one type of way or process by which the oxygen can be supplied. Today, I think that the seminar is like that. I have no very good idea about that. Our keynote speaker, he or she will very much familiar to this word. He's a researcher for a long period of time. As a research scientist, he will explain the whole things. But from biological point of view, I can say something about the MOXIE. From biological point of view, we know that the atmospheric oxygen enters through the nose and nasopharynx towards the alveoli of the lungs. Then by partition coefficient mechanism, it dissolves into the blood. And ultimately, a specific oxygen concentration is maintained into the bloodstream. That is usually called the concentration of blood. Suppose, as for example, you are very much familiar to these types of word in this COVID situation. If there may be the possibility of there may be the decrease of the oxygen concentration inside the blood, the patient may die. That is why it is very important. Our main focus is on that. The molecular oxygen usually combines with the hemoglobin of the red blood cells, which is very common in the blood in normal person. But here the science is sometimes completely silent here and completely thundered here. Though some of you who have very little chemistry knowledge, you know that for any types of bond formation, though all of you are present, they are, of course, they are the students of the science and they can understand and they have little bit knowledge on chemistry. If for the formation of any types of reaction, of course, the molecule should be atomic. That means one atomic oxygen can combine with another atomic oxygen. One atomic oxygen can combine with another iron. We know that the hemoglobin usually contains a huge amount of iron. And basically these oxygen molecules combine with this iron and ultimately it form a hemoglobin. And in this form, oxyhemoglobin form, it moves towards the cell. And when it goes to the cell, it releases the oxygen and it receives another carbon dioxide molecule. Then again, it will come back in vice versa form. It is again come back towards the lungs and then it releases the carbon dioxide. It is a general phenomenon, a general mechanism. But scientists are thundered and they're silent. They have no explanation. They have found that there is no oxygenation reaction. There is no hydrogenation reaction. There is no electron transfer. Any types of mechanism is not happening there, but the bonding is happening. And finally, mashallah, they are confused. And finally, they conclude that, but the mechanism is happening. And why these types of bonding is happening? This is the exceptional side because the oxygen is combined with the hemoglobin. It is a very loose bond. And though it is a loose bond, that is why the oxygen is in molecular form. This molecular form, it combines with the iron. And finally, it goes to the site of action. But we know that a person can survive about 40 days without any food. A person can survive any water near about to 10 days. But a person without oxygen, it is not possible to survive only for a couple of minutes. 1 minute is sufficient. If there is no supply of oxygen, the patient will die. And usually, when any person reaches to a specific altitude, there is a shortage of oxygen at the atmosphere. There is no supply of oxygen. If there is no supply of oxygen, ultimately, a person when in a very high height, ultimately he will die. At that time, but there is a available carbon dioxide is there. MOXIE is that types of machines or one types of mechanism by which the carbon dioxide splits into, you know that the carbon dioxide containing two things, one is carbon and oxygen. So it is converted into carbon and oxygen. The carbon is not required for our body. Oxygen is converted into molecular oxygen. It is introduced inside the body and the patient will survive. I have no very good knowledge about that types of engineering side. I'm just explaining the biological side. And biological side, we are very much confused. And scientists are still now, the scientists could not able to understand what is the actual mechanism is there. But the mechanism is happening. The person is survived. The oxyhemoglobin transformation is always happening. And also the carbon hemoglobin transformation from tissue to lungs is also happening. I've tried to say something in my broken speech from biology. Inshallah, all the participants will gather huge knowledge at the end of the speech of Maya Nasr. Thank you very much. I wish the success of the seminar. Assalamu alaikum.
Thank you, sir, for your wonderful speech. We are grateful for the time and the effort you took to share your thoughts and experience with us. The next dignitary to honor us with her presence is our guest of honor, Anuka Bhakta ma'am, Executive Vice President of Regulatory Affairs and Communication at Robotics Limited and Chairperson of IEEE Women in Engineering, Bangladesh section. So I'd like to call her to share a few words with us.
Thank you so much, Sarah. Good
Welcome,
evening,
ma'am.
everyone. I can see there is already 87 participants and all are eagerly waiting for this
Yes.
interesting event. And our keynote speaker, Maya Nasr, is here, so she will definitely talk. So first of all, I thank the organizer, IEEE Robotics and Automation Society of IIUC student branch, and IIUC student was WA Affinity Group for inviting me. So this is a great opportunity for me to listen to this, the topic of today's discussion. I am sure it will be very interesting to all the participants here. So I'll not take much of time. I have a few slides to share with you. Just bear with me.
Yes, ma'am.
Is it visible?
Yes, ma'am, it's visible.
Okay. Just few things I would like to share. So I'm Anamika Bhakta. Right now I'm working as Executive Vice President in Robotics Limited. So in last 20 years, I'm in the telecom sector and also senior member of IEEE and serving as closely with our section. And right now as a chair of Affinity Group of IEEE Bangladesh section. I will share some of this because a lot of participants are here. You will get some information and insights for your future engagement with IEEE. You all know what is IEEE, and beside that, Women in Engineering is one of the affinity group of IEEE who are actually working for promoting the women engineers and scientists so that we can bring more girls and women in the technical field. So this is the overall objective of Women in Engineering. And globally, in 70 countries, we have 15,000 members, more than 15,000. And there are more than 600 Women in Engineering affinity groups throughout the world. And annually, more than 1,500 events take place globally. So you can understand, if you can engage yourself with this platform, how you can interact with the renowned person speakers globally, and also it will help you to develop your skill, your knowledge, and it will increase your networking significantly. That I can assure. So overall vision and mission of Women in Engineering is to inspire the high school girls so that they take the technical fields and engineering, engage them in technical and professional skill, engage the female students to with professional and technical skills development, encourage them to acquire more skills, and empower them so that they can take the leadership roles. So these are the 4 areas actually Women in Engineering Affinity Group is focusing globally and also locally. You all may know that there are total 10 regions in IEEE. If you can see the picture, this is the region 7, Canada, and 1 to 6 is America, and Latin America is 9, and Middle East, Africa, and Europe is region 8, and we are under region 10, which is Asia and Pacific region. And within that region, there are 17 countries that have Women in Engineering Affinity Group. And within that country, there are several student branches also have their own affinity groups. So that's why we said that there are more than 600 affinity groups globally, and also within region 10, we have huge number of women WA affinity group. When we started our journey in Bangladesh, it is in 2011, and our founding chair is Professor Dr. Celia Shahnaz, who is the chair of IEEE Bangladesh section. And under her leadership, we have been working for last 6-7 years, and because our executive committee was formed first in 2014, and from them we have started our journey, and gradually we are trying to engage more with the student branches, the females. And another point you keep in mind that the women in engineering globally, 40% member are the male member. It's not only for the female, because to progress our society, country, we need to work together to contribute and take our society and country as a whole to forward. So that's why it's not only for the women, it's both women and male can work together here, and we have 40% male membership. So this is the membership statistics of our Women in Engineering Bangladesh section. From 2011 to now, last year, we have more than 1,200 members. And that's why we're saying that you can see how exponentially the membership engages. That means they are interacting with the group section events. And when we are organizing the events from the section, we always encourage our Robotics and Automation Society together, so that the members are interested people of both this group are participating this event. So ultimately the number of beneficial is much more higher. So right now we have 17 WA student branch affinity group in our country in 17 universities. So we are trying with other universities also to open the Women in India Affinity Group. We have some flagship events as well as some local events. What are the flagship events? Like Women in Engineering International Leadership Summit that we organize after 2-3 years interval. And globally it takes place in different countries. So you can search for it. And this is a very strong platform for especially for the females to participate and engage yourself with the global events, and so that you can enhance your skills and your knowledge in the technical areas where you are interested. And another is Week on EC, Women in Engineering conference for electrical and computer engineering. This is one of the flagship event, and it has been founded in Bangladesh by our section chair, Dr. Celia Shahnaz, and we are organizing this event every year. And this event we are not doing in our country, and we are trying to make this organization with other countries, even like last time we did it with Thailand WA Affinity. Earlier we did it with Pune Affinity Group. So it's a collaboration beyond the countries. So it's increasing its reach and connecting us more with global experts. Another one is SWYM Congress. This also takes place every year for all types of members, and this is also another great platform. And we have V-Power, so it's related to, it's a World Bank initiative, and every year we organize a number of events related to power, where you can, if any of the participants who are present here, you are interested to build your career in future in the power sector. So this is a great platform for you to engage or connect with. Beside this, every year we even organized 20 to 22 impactful events with different student branches. We also do outreach program that we have already earlier mentioned, that we need to encourage our schools or college going females to come to the technical field or engineering field. So we have to start it from the school level. So that's why every year we try to do at least 1 or 2 outreach event with different schools to encourage the students of that or those schools. Beside that, there is a humanitarian technology-based event, which is one of the key focus area of IEEE. So you can also think of this area. So why I am sharing this event, because you like the event you have planned today, you can also plan for any kind of events. Now you see this technical, the impactful event that I have mentioned. It's not only need to be a leadership or something like that. It can be a technical topic space where you can find out a resource person, or from the section we can help you with a resource person, and you can organize with us, and you can ensure the participants, so that the ultimate objective of all these events is to create an impact on the participants, on the students of Bangladesh or WI or IEEE members, so that is the overall objective of organizing this. So keeping that in mind, so I will request IIUC to sharing this information, so that you can plan and you just inform us, and we are always ready and eager to collaborate for any events with any university student branch or Affinity Group. So that's all from my side. Thank you.
Thank you so much, Anamika ma'am, for your informative speech. We are really honored to have you among us, and really grateful that you shared your time with us, even being busy with your own schedules. Thank you so much, ma'am.
Thank you all.
Now, with delight, I would like to call our station chair, Professor Mohammad Shamsul Alam sir, Associate Professor, Department of CSE, IIUC, to take the floor and share his thoughts with us.
All the distinguished guests and dear student, Assalamu alaikum.
Walaikum assalam, sir. You are audible.
Assalamu alaikum, sir.
Actually, all of us are waiting for the speech from our keynote speaker. So I don't want to give a long speech. Rather, as a chair of this session, I want to give a vote of thanks. So at first, I thank our keynote speaker. I think no need to give brief description on her. All of you know about her, and we are waiting for her speech. Then I thank our chief guest, Professor Dr. Mohd Akhtar Said, Dean, Faculty of Science and Engineering. In our all programs, when we invite him, he's so kind that he joined with in our all programs. So I thank again him. Then I thanks our guest of honor, Anamika Bhattro. She gave a brief description about IEEE Women in Engineering Bangladesh section. I think all of our members of WIE inspired with his speech. And last but not the least, I thank our today's organizers, IEEE IUC Affinity Group and IEEE Robotics and Automation Society ISC student chapter. As a very young chapter, they organized some qualityful webinars. Hope this today's webinar will also a very good webinar. By this vote of thanks, I want to conclude my speech. And thanks again, all of you, for participating in this webinar. Thank you. Assalamu alaikum.
Thank you, sir, for your wonderful speech. We are grateful for the time and effort you took to share your thoughts and experiences with us. Thank you so much for coming, and we are extremely grateful to have you with us today. Thank you, sir.
So now moving on, as we all know, pandemic has pushed us all against the wall to arrange all the meetings and sessions online, but we might as well use this as an opportunity to organize international events, as we don't have to worry about time barriers or traveling anymore. So that's the opportunity we took to invite our today's keynote speaker. So I hope everyone will keep patience and stay connected with us till the end. Let me introduce everyone with our keynote speaker, who is none other than Maya Nasr, a native of Lebanon, who received her bachelor's and master's degree in aerospace, aeronautical, and astronautical engineering from MIT in 2018 and 2021, respectively. Currently, she is a PhD student in Aerospace Engineering Department at MIT, working with Professor Jeffrey Hoffman on the Mars Oxygen ISRO experiment, which is also known as MOXIE, for NASA Jet Propulsion Labs Mars 2020 mission. So let's get to know more about Moxie and her experience directly from our keynote speaker today. So with delight, I would like to call Maya Nasr to take the floor. Hello, Maya.
And thank you so much, Zareen. Thanks for the introduction and thanks for organizing this event. I'm really happy to be here. And thanks for all the previous speakers who introduced the project a bit and the work. So I'm really excited to be talking to you all about our work, what's happening in the new Mars missions, and tell you a bit more about my background and how did I get into working into the sector, and really try to have an end for my presentation focused a bit more on tips and advice for women, specifically in engineering, because it's such an important topic, and I'm really glad this is being discussed more and more in events. So let me share my screen and we can get started. To confirm, can you all see my screen?
Yeah, we can see your screen.
Fantastic, awesome. All right, so again, thank you so much for having me today. I want to start a bit by giving you a brief background about myself and how I got involved. Then we can talk about the Mars 2020 mission and the MOXIE project on it. So as Zareen mentioned, a brief background about myself. I was born in Lebanon. I'm currently 24 years old. In 2011, I got accepted to a program in Lebanon called Competitive College Club, known as CCC. And that allowed me to apply and go to the US, where I got my undergraduate and master's degrees from MIT in aerospace engineering. And right now I'm working on my PhD, hopefully finishing in the next couple of years in the area of aerospace engineering as well. So the way it all started is in school, I've been always very, very interested in the area of space and in the area of aerospace engineering and really trying to contribute to that field in general. But being in Lebanon, that was not an option around. If you're interested in the space areas, you really don't have any opportunities, neither to study nor to actually work in it. So I remember once I was in school, this is a photo of my school that you see over here. I saw basically a banner that talks about this program called CCC and shows like few really prominent universities, including MIT and Harvard and such. And I was like, maybe I should try to apply to that one. So I went home, talked to my parents. I was like, so there's this program in Amidis, which is an organization that allows you to apply and go to the US. Do you think I can, apply? And I was really young at the time, and my parents were like, okay, it just sounds like an interesting opportunity. And we all, moved forward with the process. They were very supportive. But it was always as something more like a joke. It's not something that's really going to happen in the future. But thankfully, I took this photo from Amity's website. I was able to get to my dream school and to be starting to actually get opportunities to work on something I love and enjoy, like the work in the space sector, throughout this program. So I always like to give a shout out in any presentation I give for Amity's and the programs they give to encourage students and help them out and applying to opportunities outside of their countries. And this is just to show you the moment that actually got accepted to MIT. This is MIT, as a fun fact for all of you, sends admissions on Pi Day because it's an energy institution. So we get our admissions on March 14th. So this is kind of the moment that actually allowed me to start working on that. But throughout my high school, when I was still up in the process of applying and still in the process of figuring out what to do next, something really exciting happened in 2012. And you can see here the photo and the slide. The Curiosity Mars rover landed on the surface of Mars. And for me, that was an incredibly exciting moment because it's such a big event and such a big next step for all humanity to be able to land something as complex and as fascinating scientifically on the surface of a different planet like Mars. And specifically in the Mars landing, I saw this person over here, and this person is Dr. Charles Al-Ashi. He's a Lebanese American. He was the previous director of NASA-JPL Propulsion Laboratory. And for me, he was always someone that inspired me, and seeing him there, you know, as a previously Lebanese person who grew up in Lebanon and really moved to the US and really led all of these endeavors, really inspired me and gave me someone to latch on to in terms of working and trying to apply. So that motivated me even further to really start my work and really start applying to go to the United States. And this is a photo to show, finally, if you fast forward to a few years later, that was my very first internship at NASA-JPL Propulsion Laboratory. I had the honor to work with Dr. Charles Al-Ashi on several projects that I'd be talking about in a bit. But it was a quite incredible experience to finally be able to meet him and have the guidance needed in that domain. So I previously, just a brief recap, I previously worked on a bunch of different projects. My PhD is focused on the Mars Oxygen ISRU experiment, MOXIE, which I would be spending the big portion of my presentation today on. But at JPL itself, I've worked on multiple other projects, including the Cassini mission activity on Saturn and Titan, where we try to look at radar and BIMS data of Titan's surface and try to extract new information about the analysis of the rim lakes that are on the surface of Titan. I worked on the Saturn probe mission, specifically on its attitude determination and control system. Worked with OneWeb on their satellite constellation, and at MIT, I had the opportunity to be involved in various satellite activities and satellite projects that we've worked on, both for Earth observation purposes and for deep space navigation purposes. And I was really fortunate to have various opportunities of organizing separate programs in engineering, robotics, and entrepreneurship between the UK, India, France, Peru, and Colombia. So generally got really fortunate with all the opportunities that MIT allowed me to do over the last few years. One thing that I'm currently working on that I'd also love to share with you all and the group is a project that will be launched to the International Space Station this or next year. And this project is called the Humans Project. And the idea behind it, in addition to my passion towards engineering, I'm very passionate about increasing space access and space representation worldwide. So if you look at currently the status of space activities, the International Space Station is one of the really few avenues that you have multiple countries collaborating on a space mission. But still, if you look at the countries involved in the ISS, it's just the major spacefaring countries. And what I'm really interested about is increasing the access of different people in different countries that don't, necessarily have space activities going on in their countries to be able to be involved more and more, and to be able to have space actually more representative for more people around the world. So this project will be launched actually next week. So you might be hearing a bit more about it, and you'll be all invited to really send out your messages and your voices to space in your own native languages to represent your country and your thoughts and your opinion on space, or what does space mean to you and to humanity throughout this project. I also want to talk about something before we start talking about the Mars projects that we're working on, which is an area that not a lot of people are involved in, but I have a lot of interest and kind of trying to always do that in parallel to my engineering work, which is space law and policy. So I'm currently one of the leads in the Space Law and Policy Group and the Space Generation Advisory Council. And we're working on various projects. But for me, one of the main things that I'd like people to think about when it comes to any engineering activities is the policy factor of it, and to think about the ethics behind it. So whether we talk about robotics, whether we talk about AI, whether we talk about space, we need to think about, as engineers, always consider the ethical aspects, the policy aspects of any activity we do, including, for example, peaceful use of outer space. How do we avoid weaponization of space? How can we ensure we're doing peaceful exploration, and to have more international collaboration between countries? So this is an area that I'm very interested in, and I'm happy to also answer any questions about it in the Q&A after the presentation. So to get started to talk about the Mars projects, I'm gonna flash back to my very first class of aerospace engineering at MIT. So I still remember entering the class, seeing this photo basically presented in class, and there's the professor standing in front of it. So I was like, oh, that's a really cool photo, it's an astronaut. I really wanted to be like that. I just didn't think it through more than that. Then the professor started talking, and he's like, so when I was up there fixing the Hubble telescope, and for a moment, everything that happened afterwards just like stopped, and I had to think, I'm like, wow, so many questions flashed in my mind. Were you the person in that photo? Were you in space? Were you fixing the Hubble telescope? And that was really like the first professor that I've met. And it was really incredible for me to kind of get accustomed to be surrounded by smart people, by people who are all working on amazing activities, by people who are very supportive in these missions. And lucky enough, this person is this guy over here, who currently looks a bit different, as Professor Jeffrey Hoffman, who's currently my PhD advisor, and he's deputy PI on the MOXIE project on the Mars 2020 rover. So I had the honor to work with him for the last many years on this project, and to have his advice and guidance throughout this work. So that being said, I'm going to transition to actually talk about Mars right now. What I'm showing in this photo is basically an overview of the Mars exploration programs. And one thing you can see here, the Mars Odyssey in 2001, Opportunity rover in 2003, the Mars Orbiter missions in 2013. You can see Curiosity over here, 2011. And you can see here the Mars 2020 rover, which is the mission that I've had the opportunity to work on. And that is currently the what's going on Mars, basically. And one thing that I'd like to really point out that always fascinates me when I look at such an overview is, for anyone who's about 17 years old or younger right now, there has been for their entire lifetime an active rover on the surface of Mars. There has been someone at NASA-JPL who has every day been, waking up and driving the rover on the surface of Mars. And this is always incredible to think of how far we have gone in terms of technology, in terms of robotics, and in terms of space exploration to be able to do something as fascinating as this. So to give you just a bit of an overview of the past Mars rovers that led into the Mars 2020 rover that we'll be talking about. So these are the past rovers that the US has landed. First of all is Sojourner. You can see, just to know, they're all increasing in capability, and Perseverance is just kind of the amazing latest one of these rovers. So Sojourner in 1997, it's a very interesting mission. It was successful, was able to take pictures. It didn't travel very far though. Its top speed was about 160th of a mile per hour, which is really, you walk at about 2 to 3 miles per hour. So you're it kind of moves about 200 times slower than you walk. So it didn't go somewhere really far, but it was such a big step for us to be able to send something like that to the surface of Mars and be able to take pictures and really understand a bit more about Mars and the surface of it. In 2004, twin rovers, Spirit and Opportunity, were landed on the surface of Mars. They were kind of built in a similar manner, because they were they were sent to 2 different parts of the surface of Mars to explore that differently. Both of them were great missions, gave us a lot of scientific information. Spirit's most important discovery was being able to get its first ever footage of dust devils on the surface of Mars. So it basically took a bunch of photos that once you stitch them together, you can get kind of a video of these dust tornadoes on Mars. And that was extremely scientifically important to know how dust storms behave on Mars, that there is even dust storms on Mars, to really understand scientifically more about what to expect when we send other missions in the future. Opportunity discovered something really interesting, which I would show over here. And this is what it's known as the blueberries. So these blueberries, if you can see here, as zoomed in photos on the right, are basically hematite-rich spherical rocks. And why those are interesting is the fact that on Earth, once we see something that is spherical rocks like that on the surface, that we only associate with previous flow of water on the surface that could able to kind of shape the rocks in a way that are this nicely spherical rocks. So the reason why this is important, because if we observe this on Mars, then this could give us some evidence that there was flow of water in the past that was able to show and to shape these rocks into this form. And this is the reason why having water is important, because in our endeavor of searching for life on Mars, having proof of water on the surface of Mars is incredibly important to give us, or at least previous flow of water, could give us a lot of insight about the current and the past status of existence of life on Mars. So unfortunately, both of these missions were very successful, but unfortunately, both of them ended their missions. So you can see over here, the Spirit rover in 2011, you can see its wheels here got stuck in the actual surface of Mars, and basically wasn't able to drive itself, couldn't dig itself out of it. And the solar panels that it has, given that we showed, the dust devils on Mars, were covered by dust and were not able to power the rover anymore. So it kind of ended its mission over there. But still, it was an incredibly amazing mission. It gave us a lot of science. And only a few years ago, we actually lost the Opportunity rover. And the reason it lost is also because of a dust storm. What you're seeing over here in the photo on the right is a photo if you are looking towards the sun, and you can see how the light is dimming and dimming and dimming as the solar panel is being covered with more dust because of the dust storm over there. So it eventually was not able to power itself. As both of these, or all of these rovers, are just solarly powered. So both of them are amazing missions. We lost them, but they led us to the amazing Curiosity rover in 2012 that we talked about. So Curiosity landed on the surface of Mars in 2012 in Gale Crater. It was the very first time that we had a nuclearly powered rover on the surface of Mars. And the reason why this is important is, as I just mentioned, all the previous rovers that were just powered by solar panels, because of the dust on Mars, that causes a lot of possibility of the stop of power in terms of anything going wrong in these solar panels. So this was the very first time that we're able to do actual increased amount of science, because we have a different kind of power source on the surface of Mars. So Curiosity has been doing amazing science since it landed. It gave us a lot of information about the geology on Mars, evidence of past water. It has drilled, analyzed samples of rock. It's really an incredible, incredibly successful mission that led us to the Mars 2020 Perseverance rover. And what you're going to notice, or if you know that before, the Curiosity rover and Perseverance look very much alike. There's a lot of common used or reuse of technology between both rovers because of how successful this Curiosity rover was. So Mars 2020, which is the mission that we're all so excited about and we're going to be focusing our conversation on. Mars 2020 is currently the most recent mission to Mars. Its main mission objectives are: one, seeking signs of past life on Mars. And this is important because we get into the geology of the landing site, and we're really, be really excited to begin exploring this landing site and understanding its past geology, and how to look at the sediments in the landing site and try to scientifically analyze what's going on there to see if we can actually find any evidence of past life. On top of that, another big thing that Mars 2020 is doing is setting aside caches of samples. So what Mars 2020 is going to be basically doing is it's going to drill a coring bit and actually takes rock samples about 2.5 inches long by like 1/2 inch in diameter. It will put them in little cylinders and it will store them. And it will put these cylinders bundled on the surface of Mars. And in the future, a future mission called Mars Sample Return will be flown into Mars, will go there, take these samples, fly back to Earth, and give them to scientists to be able to further analyze what's going on. So this is a very important capability that Perseverance is doing. And finally, and most importantly for me, Mars 2020 is really preparing for future human exploration on Mars. And this is very important because right now we have enough technology to be able to send humans to Mars, but we want to be able to sustain them and be able to return them safely to Earth. And this is where the MOXIE experiment, which I'll be talking about, is going to be the most important aspect of it. So this is just a photo of the Perseverance Mars 2020 rover. Again, as you can see, it's similar a bit to the Curiosity rover that I've previously shown. You can see some of the instruments right here. You can see here the Sherlock instrument on top of the robotic arm. And this is MOXIE. If you can see over here, it sits right in the front side of the belly of the rover. And it's basically just a really amazing technological advancement when you look at such a rover with such complexity. It's heavier, it's more complex, carries more scientific instruments than Curiosity, and it's been so far giving us a lot of amazing discoveries about the surface of Mars. And on the Mars 2020 rover, there are 7 science instruments, which I'll be showing over here. I won't be going through the details of these science instruments, but we have a bunch of advanced cameras that would do panoramas, stereoscopic images, basically like mass cam. SuperCam is very interesting because it would basically detect organics from a distance. So it has a laser that basically beams and clears away the surface for about up to 20 feet, which is really cool. It vaporizes the rock and it measures the light resulting from the rock plasma. So it's a really cool instrument. We have MEDA, which is our kind of weather monitor of what's going on in Mars. We use it in our MOXIE instruments as well to get information about pressures and temperatures in the atmosphere. So as you can see, really exciting, really interesting bunch of instruments. They're all stacked within the belly of the rover. And what you can see over here is the MOXIE instrument, which is the one that I will be talking about for the upcoming slides. And MOXIE again stands for Mars Oxygen ISRU Experiment. It's a a payload that has a whole different agenda on its own, and its main goal is to really try to prepare for future human exploration on Mars by producing oxygen from the surface of Mars. So let's talk about why this is important. First of all, something for anyone who's not as familiar with the space sector. Sending propellants or sending anything basically to space is extremely expensive. So if we want to be able to send people to Mars and we want those people to be able to come back to Earth, we have to basically send a rocket, put the fuel and the propellant that it needs in the rocket, send them up to Mars. And on Mars, we use something called a Mars Ascent Vehicle, an MAV, to be able to take the astronauts at the end of the mission from the surface of Mars, basically hire them up to orbit and have something else that will take them back to Earth. But in order to do that, hiring up the surface and going back to Earth, this whole process is going to need a lot of propellant. And if we currently, the way we're going to do it is we basically take everything from Earth, which is incredibly expensive. So if we have a crew that we want to get off the surface of Mars, if you look at the numbers over here, we're going to need about over $1 billion to be able to have the propellant carried from Earth to be sent to Mars for these humans to come back safely to Earth. And from here, this raises an incredible importance of the use of what we call in-situ resource utilization, which is the idea of living off the land, basically producing things from the surface of the planet instead of carrying things with us from Earth up there, which decreases cost and decreases risk and increases the longevity of any mission. You can think about it as if, if you're going backpacking and if you had to carry with you everything on your way before you even leave, you are quite limited to how far you can make it in your trip. But if you fend for yourself and kind of fish along the way, water along the way, you won't have to carry everything with you, and that way you can last a lot longer. So similar aspect, but right now we're talking in an application in space. So when we talk about space missions, though, specifically on Mars, there are a lot of available resources on Mars that we can use for such purposes. And these available resources are mostly CO2 in the atmosphere, because we have over 95% of the atmosphere as carbon dioxide. And we have water, which is in two forms, basically hydrated regolith on the surface of Mars, in addition to water ice under the surface. So it kind of makes economic sense that we produce what we need in terms of propellants and such from the surface of Mars instead of carrying that with us from Earth. And this is where MOXIE comes to play. So MOXIE is the very first time on any different planet that we produce or we do in-situ resource utilization. As was mentioned before, MOXIE produces oxygen from atmospheric CO2 at a higher than 99% purity. And the process that it uses is called solid oxide electrolysis. I'll be talking about this in a bit, but I want to re-emphasize the importance of this. I think there was a lot of talk about the use of this oxygen for breathing of astronauts, and that's extremely important. So if we send people to Mars, two of the things we need them to do is to really breathe and survive. So they need oxygen for that, and this oxygen produced by a scaled up version of MOXIE is definitely important. But to be honest, the biggest portion of this, the importance of this produced oxygen is for rocket propellant. So as you know, for propellant, you need a fuel and oxidizer. So if you get the methane or hydrogen with you, you've got the other part, which is oxidizer, that takes up a huge amount of mass, which is why producing it off the surface of Mars is economically better. So the process to actually produce this oxygen, it was explained a bit at the beginning, but as you know, CO2 has two oxygens inside of it. So if you actually sandwich or basically solid oxide electrolysis kind of sandwiched between an anode and a cathode side, where if you take the CO2 at a really high temperature of about 800 degrees Celsius and apply electricity, you could oxidize what's going on and basically take the oxygen ions and have them recombine and produce molecular oxygen, which could be used as an oxidizer and as oxygen for breathing. So it's a very important technology that was just demonstrated, and it has been done previously in labs and such, but it was the very first time that we actually do it on the surface of a different planet. This is a photo that I really love of our MOXIE instrument. You can see here the gold box. While it was on Earth, it was right now kind of inserted into the belly of the Mars 2020 rover and the clean room. And one thing to know, you can see it's gold plated, and that's because we operate again at about 800 degrees C, and the gold plating protects any thermal heating or such for the other instruments surrounding us, because we operate at such high temperatures. So again, MOXIE is about the size of a car battery. It's about 17 kilograms in mass. It's located inside the rover. And it consumes about 300 watts of power. These are just general specs if you're curious about them. And on to Mars. So where's Perseverance right now? And what happened since we landed on the surface of Mars, the main accomplishments of the mission so far. So this was a photo, a video of the launch, which was super exciting. It happened on July 30th. We've been almost a year to launch right now. And it was incredibly exciting. I think given how 2020 was going, I was freaking out about something going wrong because of how all the bad events happening that year. But we thankfully were able to launch successfully. And about 8 months later, we made it to the surface of Mars. So these are really exciting photos that were the very first photos that were taken from the surface of Mars. What you can see on the top ones are basically the hazard camera photos from the rover. And they're covered a bit with dust, but that was like on landing. And the image below is super cool, which is an image taken by the HiRISE imager, which is on one of the orbiters around Mars. It's called the Reconnaissance Orbiter. And if you zoom in to the photo over here, you can see this is the landing site, and you can see the parachute that was basically taking the Mars 2020 rover and its entry, descent, and landing, and basically to land it on the surface of Mars. And this is another really cool photo of the sky crane, which is when basically the cables that were lowering the rover to land softly on the surface of Mars. And this is, to know, one of the coolest things that happened in this mission is it was the first time that we have actual videos, actual photos of every part of the entry, descent, and landing, which is incredible. That has never been done before. And it really gave us a lot more insight to understand how the landing works and really get some super cool images about the surface. Until finally, this is the selfie that Perseverance is taking with Ingenuity. And this is a really cool technology demonstration that I didn't talk about yet, which is the helicopter called Ingenuity that is aboard the Mars 2020 rover. You probably have heard about it on the news as well. And it's the first time that we're able to demonstrate flight on another planet. So if we're able, right now it's definitely limited by a lot of things, but the reason why this is very challenging is, you know, the atmosphere on Mars is extremely thin. So you cannot operate helicopters the same way you operate them on Earth, because it's really hard to create lift and to fly. So it's very impressive to be able to demonstrate such technology. And it's very important for future missions because, as I mentioned, these rovers are incredibly slow. Even the Perseverance rover, it is slow in the way it walks. So if we have ability to navigate with something that flies, with being able to take photos from top, being able to do a lot of these things. This is very important, and being able to demonstrate it now and make it better and better in future missions is kind of the end goal of this. So what has been our timeline for MOXIE on Mars? So we landed on February 18, 2021. It's been a very exciting experience since then. And then we've had the first few months, the helicopter flying, the first oxygen run, the rover began driving. And for MOXIE, or especially, for general missions, there's technically kind of a 1 year of planned operations. All of these rovers are designed to, or like tested for this 1 year of operations, but they normally last a lot longer. Like you can see, Curiosity has been since 2012 and still giving us amazingly valuable information till now. So I want to give you just really exciting first results that we got. I was really fortunate to be doing the analysis and be able to get the first data that we got from Mars on this, which is the very first oxygen that was ever produced on Mars. And that happened on April 20th this year. We were able to produce 6 grams per hour of oxygen with a total of about 5.37 grams of oxygen. These can help keep an astronaut healthy for like 10 minutes of normal activity, which, is little, but MOXIE is a technology demonstration. So NASA would not be able to send any technology with humans if it has not been demonstrated that it works properly before. So being able to demonstrate that was a huge step, because right now in future missions, we can scale up MOXIE, make it a lot bigger, make it be able to produce a lot more oxygen so it can support astronauts for a longer period. But since then, we have made a bunch of other runs on Mars under different operating conditions in order to actually prove that we can produce oxygen in multiple seasons and multiple days of the night, day and night, and such activities to kind of prove an overall verification of the system. And some other really cool achievements that Perseverance has done so far is we've had 9 Ingenuity helicopter flights. We've had the first auto-nav drive successful, which is incredible because it's the first time the rover was driving by itself. It has kind of a really powerful auto navigation system. For any of you guys that are interested in kind of this work in robotics, it was a very successful thing to read about more. Basically, the AutoNav system basically is an enhanced system that can make 3D maps of the terrain ahead. It can identify hazards, plan around a route for the rover to move in. So it was able to successfully do that, to be automatically be able to navigate on the surface of Mars. We produced the first oxygen, the first ISRU demonstration. We were able to get sounds and a lot of super cool imagery from Mars, which is incredible for scientific purposes. And right now we're starting, as the rover started driving, we're starting to actually dig into the science and take photos and really start to understand rocks on Mars and start to understand the geology behind what we're working on. So the work right now is really focused on what we call as uplink and downlink, which are the Mars surface operations on MOXIE and other instruments. And what that means is sending information up from Earth to Mars. And the downlink part is basically receiving the information through orbiters to deep space network antennas and taking it back to Earth. So right now I'm leading the downlink part of this operations, which is basically getting the information from Mars, doing its analysis, reporting on it, and identifying any faults or any interesting analyses that we find. It's a very, stressful but very interesting role to be in, because you're kind of on the spotlight. Everyone's watching you while you're doing all your analyses. You have a very short period of time where you have to report on the data to NASA about what you see, anything interesting, good or bad, and what you see. And one thing interesting, what we've done in the first part of Mars surface operations is we were operating on Mars time, which means we were operating nocturnally on the day, basically the night time in Boston. So that was a very interesting experience to be able to be involved in that. With that being said, I hope I got a lot of you excited about Mars, about the current mission we're doing, and I want to end it on one slide regarding challenges and advice for women in STEM. And one thing that's important that was mentioned before is I'm really happy that we have a combination of both men and women on the Zoom call, because it's always important when addressing these topics to have everyone involved, because you can't solve the problem if you're just talking to the women. You need to talk to everyone involved in the situation to be able to make a difference. So some of the challenges that a lot of women face, including myself, including a lot of others around the world, is we always are under a different spotlight. We always feel like we are there to prove ourselves and to not make any mistakes, because any mistake that we do, it's kind of proving the point of why we shouldn't be do science. So we're always feeling like we're under a different spotlight. It's a lot more stress in terms of being able to provide more evidence to prove that you're competent enough all the time, while men don't have to do that. And this is something that's very important for women to understand, that a lot of other people are feeling that way, and for men to understand the actions or how to navigate that part around to make women feel comfortable, to make women, feel valued, and to prove their competency equally as men do. And one of the biggest problems is the lack of support that women have, even from female colleagues. And there's a lot of female colleagues that, have the mentality that we're raised on, that you can't do something, that you're not competent enough to do something. And that lack of support stops a lot of people from achieving a lot of what they can do. And one thing that, always annoys me is when people work, or when women get involved in such projects, is they become too bossy or not feminine enough. Or a lot of times in the US and other places, there's a myth of being, you only got accepted because you are a diversity pick. They just wanted to increase the number of women, not because you're competent. And all of these comments or jokes or anything like that are a lot of, really underestimate and really change the way women can do science and can be involved in the activities and the opportunities that they are allowed to do. So it's something very important for both men and women to be aware of and to address accordingly. And the last thing is one thing very important, which is microaggressions. And that's something that is very common in the engineering world, of like, if you are in a meeting and if you're talking, being constantly interrupted as a woman, being spoken over by men in the room, being able, especially when it comes to like Zoom calls, being able to voice yourself out. I've been lucky enough to learn over the years how to be, outspoken, how to talk about what I want, how to make my points. But that's something that takes years. And in the beginning, there's always a lot of stress when you are, like in my research, on a call with other 50-old men on a call, and you need to basically prove your point. It's definitely a lot more stressful, and it's important for men to understand that and support women in that process. And one of the things that helped me most in all of these, to overcome all of these problems, is women in engineering, basically activities and clubs. And that's why I really encourage people to take the opportunities of women in engineering that were mentioned before, and find yourself in kind of a support group of people who can mentor you, who can find networking for jobs later on, for tips, how to navigate things, whether it's academia or interesting. So most importantly, you got to believe in yourself to be able to transform how society and how science look at you and look at your opinions. With that being said, this is all I had. So thank you so much for listening, and I'm happy to take any questions you have about any of that.
So thank you, Maya, for enlightening all of us about MOXIE with the interactive presentation. It was lively, engaging, educative, and fulfilling because of your presence. So if you'll be kind enough, we'd like to take some questions from the enthusiastic participants through the chat section. So if you guys have any question, you can ask our brilliant Maya Nasr through the chat section. So you guys can just drop the question in the chat section. Okay, so we have a question for you, Maya. Could NASA's MOXIE help astronauts breathe on Mars?
Yeah, absolutely. And that's kind of the one of the goals of MOXIE is basically produce the oxygen to have astronauts breathe on Mars. As I said, MOXIE right now is a tech demo. It's a technology demonstration. So right now it produces an amount of oxygen that could keep a small dog alive. But to keep an actual astronaut or crew of astronauts, we're going to be sending, now that we demonstrated it, we're going to be sending a larger scaled up version of that in future missions.
Okay. So we have another question. What happens to those rovers that were given up on Mars?
They stay on Mars. You can go visit. They have a bunch of astronauts. There was a lot of talks about having the rovers basically drive up to see the other, or kind of meet each other. But one thing that is important to know is the locations or the landing sites of these rovers is very different, and they're far away from each other. And given how slow they move, it's not as easy to just drive towards each other. But yeah, they are given up and they stay on the surface of Mars.
Okay, so moving on to the next question. Question from Tahruma Tazeen. Why is it important to explore beyond planet Earth?
It's very important for a lot of reasons. One of the main things is we as humans are curious people. There's a huge part about curiosity, about trying to understand, are we the only life available on other planets, or is there actually life out there? Could we sustain human life on a different planet if something goes wrong on Earth? We need to understand if Mars, for example, had in the past flowing water, had situations similar to how Earth was like. Could this be how Earth ends up like as Mars in the future? What are the geological questions and the interesting things that we can learn? So all of these help us really understand and expand our knowledge about our solar system, about how did Earth come to happen, about the existence of life on different planets. So that is of crucial importance for answering a lot of our questions as scientists or engineers or just people in general.
Okay. So moving on to the next question, we have from Tanvir Alam. In order to ISRO function, we know that it needs a lot of processing power. Does it use FPGA or Wellesley generated processors?
So for ISRU, it needs a lot of processing power. I'm saying it needs a lot of power for the actual MOXIE, the actual chemical experiment to happen. I'm not sure if it's like processing power that we're talking about here. So the power that it actually needs is really to do the chemical experiment for any ISRU, which is basically the heating up of the heaters of the MOXIE stack and being able to produce things, which is why actually when we run, no other instruments actually run on the rover, because we kind of use all of the power on the rover. So we have our MOXIE sols when we do runs, and we plan the things out with other instruments so that we are the only run happening at that time.
Okay, so the next question is from Sidratul Muntaha. Doesn't it harm the environment in Mars, leaving the rovers there? Yeah, good.
This is a very interesting question. And the reason it's interesting is any rover or any instrument that's sent to the surface of Mars goes into a whole really intensely careful planetary protection guidelines. And basically the idea is we don't want to contaminate the surface of Mars by anything taken from Earth. So the rovers and everything is kind of put in clean rooms for months and months, made sure that no particle or anything from Earth can contaminate the surface of Mars. That being said, when we enter entry, descent, landing, the other stages of the entry, descent, landing are basically going to fall somewhere on the surface of Mars. And there's a lot of talk about how to make all of these things in a way that will reduce the amount of things that we leave on Mars and that we throw on Mars. But there is always a trade-off. You can't currently study things if you don't send a rover, but if you send a rover, you can't just get it back to Earth. So there is a trade-off in that sense, but at least it's being done so far very carefully to ensure there's no contamination in terms of planetary protection. And that has to become even more and more basically intense in upcoming missions, because when we start digging under the surface of Mars, when we start getting things, any contamination could spread out a lot more, and we need to be a lot more careful.
Okay, so the next question is from Samuel Azam. Billions are spent on Mars, but till now there is no beneficial outcome for human life. What will be your opinion on that?
This is a question that I got asked a lot. And when it comes to any space activities, there's always an amount of money that gets spent in that. And definitely I understand, you know, the importance, or like the when people talk about the amount of money, how is that not benefiting Earth? I want to know that a lot of the activities that we use in our everyday life have started by space technologies, GPS, you know, solar panels, solar power. These are all things that were developed for space use. And right now we're using these technologies on Earth, and they're basically running everything around on Earth. There's also the importance of fusing Earth observation technologies and space technologies to help human rights and to help activities on Earth. You know, in our Earth observation data from satellites, we can know a lot about the weather. We can know a lot about tracking any environmental changes, climate change, any things like that. We can also track things relating to immigration, things relating to political activities. And it's really like satellite imagery and Earth observation has been used a lot to aid human rights purposes and activities on Earth. Now, when it comes to Mars specifically, again, yes, it's a lot of money. Right now, there's no, that doing things like MOXIE is important because the whole idea is to reduce the amount of money and cost that goes into things like that and reduce billions and billions of dollars spent when we stop taking things from Earth and making things more, you know, done from the surface. But there's definitely going to be a trade-off. I think I'm a person that values science and values answering questions about things that we don't know, because I think that is very important to us as humans. So I do value the amount of money that goes into that. And I think at some point, if we look at the amount of money that goes into defense areas, that goes into wars, that goes into a lot of that in countries, you could realize that that compared to space is like, space is nothing compared to it. So if you want to actually talk about human rights purposes, there are bigger apples to talk about in that sense.
Okay. So the next question is from Mehdi Hassan. Once Elon Musk said that by 2030, he will send approximately 100 people to Mars. So is there any progress on that mission?
So yeah, SpaceX has been quite ambitious in a lot of these things. I think I'm a type, you know, they're doing a lot of, you know, great work, and they are increasing a lot of their technologies, which is always exciting. But I don't believe we could/should send people to Mars by 2030 for a big reason that I'm very interested in being able to develop policies and international laws and regulations that ensure the way we're doing and sending humans to Mars is done in the proper way, in a way that is safe to Mars and to the humans, and in a way that allows international collaboration, because we don't want to go up to Mars and start fighting between countries on Mars on resources and such. So I think there's a lot of caveats that still need to be addressed before we're like, all right, we're sending people to Mars. I don't think, at least regulations and policy-wise, we're ready. And, you know, a lot of engineers and scientists in space would disagree with me on this. And I have a very different opinion on it than others. I would love to see humans exploring Mars, but I want to make sure that all the regulatory stuff have been addressed before we take this endeavor, in order to make sure we don't regret it later on. Because the moment one country, you know, messes something up on Mars, that messes up things for any other country going on. And if something gets contaminated, we would not know if life exists on Mars, or if we have taken life from us from Earth to Mars. It would really mess up all the scientific endeavors we're trying to make.
Yeah, I got it. So the next question is from Fahim. Is it possible somehow to create oxygen on Mars naturally by the bioengineering process, the way it's happening on Earth?
Not as we see right now. Also, something to really important, the regulate or the surface of Mars, what it's made of, and the way the atmosphere, what it's made of, is very different on what we have on Earth. Right now, there is no oxygen in the atmosphere of Mars at all, and it's basically all 95% CO2. So you need to do some, you know, human creativity in terms of being able to create oxygen. You can't just assume it's going to be produced bioenergetically or something from the surface. So definitely that is something that would need to be done separately, as we're doing at MOXIE.
Okay, So another question is oxygen production rate of MOXIE.
Right now, it's about 6 to 7 grams per hour of oxygen produced. So it depends on the amount of the duration of the run. It differs the amount of oxygen produced, but on average, it's about 6 grams per hour.
Okay. So let's move on to another question. What things need to keep in mind to protect the electronics from Mars' harsh environment?
Yeah, so there are a lot of things, when it comes to radiation, to heat. I think a lot of parts that, need to be protected before we even get to Mars is something to be able to survive launch and survive landing, because these are two huge, there's a lot of vibration, there's a lot of, force, there's a lot of things going on there that could destroy your instruments. So there's a lot of tests and being able to make sure that the instruments survive these two events. And that's why when we land on Mars, we always do what is called a liveness check. So all the instruments, the first run that we do is not really a run on the instruments, it's basically just getting data from it to make sure it's still alive. And we do that also during cruise. So during cruise is basically the period when the rover is still on its way to Mars. It's launched, but it's not landed yet. So we actually turn the instruments on while they are in cruise, get data from them just to make sure they survived launch, and then do the same thing in landing to make sure they survived landing. So these are very important. But on Mars, some of the main things is there's a lot of dust. So any instrument you have there, whether it's cameras, whether it's solar panels, whether it's any instrument that uses something, for example, MOXIE, when we take the atmosphere and we have a dust filter. So anything that you need to do, you need to make sure it's able to overcome the dust storms and able to survive that. And on top of that, you need to think of the temperatures, because it could get really cold on the surface of Mars, like -30, negative something like that. And you need to be able to have your instruments survive that and be able to do the proper readings. That's why for anything that we do, we calibrate our basically electronics and readings from sensors in order to see how they would behave if they were made for Earth-like operations, how they would behave on operation conditions like Mars, because you've got really low pressure, really low temperature, and you've got a lot of dust, and you've got landing and launch to survive. So there are big contributions from there.
Yeah, got it. So the next question is, does MOXIE do anything else besides producing oxygen, like searching for living elements or something like this?
No, so the idea of MOXIE is to produce oxygen through this chemical process on Mars. The search for life, quote unquote, is happening via the samples that the rover is taken that will be, sent back to Earth and studied afterwards. And also done via the cameras and via the instruments that study the geology of the surface, basically, and study the rocks and be able to understand what are the rocks made of, what are the chemicals currently available, and the sediments and on the landing site. Something to note that's very important is we landed right now on Jezero Crater, which has a delta river. Basically, if you look at the surface, it has the shape of a delta. And the reason why that is very important geologically is that tells us that in the past, there was flowing water here to be able to form this delta shape. And that's why there could be, like on Earth, if you have any flowing water, it creates sediments, and these sediments could save life. So that's why we're studying these areas, because they could give us insights about possible past life that could have existed on Mars. But that's the general idea of the rover, not of MOXIE.
Okay, so let's move to the next question. Is from Mehdi Hassan. Once I read that the size of volcano in Mars is as large as the size of the 3 Everest of the Earth. Is it true?
Well, I mean, there are multiple volcanoes on Mars. They're big. I don't have a specific number for how big they are right now, but they're definitely huge volcanoes and huge craters on Mars that could potentially be this size. But I don't have a specific answer on that.
Okay, so
Hello, am I audible?
Yes, you're audible.
Okay, I want to ask one question. First, congratulations, Maya, on the success of MOXIE. My question is, how are we so sure about what MOXIE is producing is oxygen? Is there any sensor or any chemical reaction that confirms that?
Yeah, 100%. So we have oxygen sensors on MOXIE that actually produce that actually measure the amount of oxygen produced, and that verifies it's oxygen. And also we have a chemical reaction. You can measure the current, and the current is basically directly correlated to the amount of oxygen produced. We also have sensors of other gases to confirm purity of the oxygen, to basically confirm that the amount of gas produced is just oxygen and it doesn't have impurities from other gases like CO2 and such. So we are proving that throughout this experiment for sure.
Okay, I think that's the end of the question answer session.
Okay, a personal question from me, Maya, to you.
Yeah.
Like, I have noticed that you are also involved in writing poems and also interested in painting. So where did you get the inspiration from?
Sorry, I didn't hear the last part of the question. I think
Okay, like you are also involved in writing poems. It's wonderful. I have seen some of the poems, and the paintings are also amazing. So where did you get inspiration from?
Yeah, I think I'm the type of person who, I enjoy science a lot and I love engineering, obviously, and I love working in that, but I'm very interested in arts as well on the side. So I kind of, I feel like I always need that in parallel to what I do to be able to enjoy, different parts of what I do. And I think there's always a understanding of like engineers being just pure engineering and that's all you do in life, which is not true in a lot of cases, because you need a different type of creativity to kind of let go of different ideas that you have. So for me, painting and writing poetry is important, and poetry is interesting for me because it's one of the few ways that I keep writing Arabic, which is my mother language, and otherwise I'm not speaking with anyone around here. So it's one of the few ways that I keep that going. But yeah.
Yeah, thank you so much. And I think that was the end of the question and answer session.
Am I audible? I have not a technical question to Maya.
Okay.
Hello, Maya.
Hello.
Thanks for joining to us. Actually, I have a non-technical question to you. That I found that you came from Lebanon. So somehow I saw a movie that Lebanon and saw a village named Al Haifa. So do you know about it, or actually it exists in Al Haifa, a village in Lebanon?
I don't fully understand your question.
Actually, I'm just talking about Lebanon's village, Al Haifa.
Al Haifa?
Al Haifa.
I don't think that.
Oh.
I don't think that's.
I think
Lebanon.
you didn't know that, but I actually found Beirut. That's your city, but I actually found that Al Haifa, there is a village. So actually, I read some article on it. So that's why I'm going to ask you this question, that you know about it or not.
Yeah, no, I don't think I know about. How is that related to space in that part, in that town?
That is actually related to Syrian border, the village.
Yeah, I'm not sure about that part.
Okay.
I don't think I know it.
Okay, thank you.
Okay, thank you, everyone. I think that's the end of the question and answer session. And thank you, Maya, for giving us your time from a busy schedule. And we are very grateful to have you with us today.
Yeah, thanks so much for having me. I hope that was helpful.
Yeah, sure.
Thank you so much, Maya, for your wonderful Q&A session. We enjoyed it a lot and learned a lot from you today as well. So as we know, due to the pandemic situation, we are not able to give out our token of appreciation in person. So we are going to show our token of appreciation through the screen share. So now I would like to share the token of appreciation with our brilliant keynote speaker, Maya Nasr. Thank you so much. We'll send it to you via our email. So now I would like to request all the audience to turn on the camera if possible, so that we can take some screenshots to have some memory of this event. I will request our executives to take some screenshots. Please let me know if you're done with it.
You can continue. Screenshots are taken.
Okay, thank you. So we have sincerely approached to the end of the program. It was an honor and a great pleasure to have you among us, Maya. Thank you once again for your time and sharing your experience with us. I'm sure that everyone learned and acknowledged a lot from today's session. And I would like to thank our honorable guests and participants who stayed connected with us throughout this event, and also my team as well, who worked hard to make this event a success. So approaching the end of this session, we wish you a very happiness, prosperity, and peace from all of us at IEEE Robotics and Automation Society, IIUC Student Branch, and IEEE IIUC Student Branch WIE Affinity Group as well. So wear your mask and stay safe, everyone, and have a very good night. Thank you once again for joining us today.